Right, in the previous video I talked a little bit about an overview of functional dependencies and why they are important in allowing us to characterize goodness of schemas and to give us a handle on discussing the redundancy that was potentially in a schema. Functional dependencies are also important, and maybe that's the reason why we use them for those other two tasks, because they have some nice mathematical properties. So that's what I wanted to talk about in this video. Okay, so one thing that functional dependencies allow us to do is to characterize the notion of keys formally. So we can say that a key for a functional dependency will be a set of attributes, and those attributes functionally determine all of the other attributes. So given a particular value for a key, we know what the value for the rest of the attributes are. So if we had, let's say for the sake of argument, AB functionally determining C, D and E, then we could state that AB was a key of that table. So here we're talking about a relation which has the attributes A, B, C, D, E. So AB would form a key in that situation. Another interesting mathematical property of functional dependencies is that we can define a collection of rewrite rules, so that when we want to talk about whether some set of functional dependencies is equivalent to another set of functional dependencies, we can transform the set of functional dependencies using these rules, and if we can transform it from one state into a different state that's equivalent to the one we're looking for, then we'd know that the two things are equivalent. And one simple rewrite rule is to allow us to say if A determines B, C and D, then that's equivalent to A determining B, A determining C and A determining D. And since it's equivalent, we could go back the other way. If we happen to know these three functional dependencies, then we could write them like that. So this set of rewrite rules is quite important. Another interesting set of mathematical properties related to functional dependencies is the notion, very important notion, of normal forms. So normal forms characterize, in some sense, the level of redundancy in a schema. So, and they come in different levels. So the first level, first normal form, basically it gives you no guarantee that the schema doesn't have some redundancy. Basically, all it tells you is that a schema is in first normal form if all of the attributes are atomic, which is kind of what we assume with the relational model anyway. Then there's second normal form, which basically just talks about keys. These two normal forms aren't interesting. If we've got a schema in one of these two normal forms, we're not going to be particularly happy because it would have the redundancy properties that I talked about before with the attendant update problems. Then there's two related normal forms, third normal form and Boyce-Codd normal form, normally abbreviated to B, C and F, and these are the kind of properties that we're looking for in our schemas. So a schema which is in one of these normal forms is not going to have the kind of redundancy problems that we talked about earlier. Now, we can certainly analyse a schema and detect whether it's in one of these normal forms, but if it's not, what do we do? And the third interesting property that we can have with functional dependencies is decomposition of schemas. It's more of a process than a property. Decomposition. So, if we've got a schema, and let's just imagine we've got a giant table with all of those attributes in it. If we decide that it's not in an appropriate normal form, what we might be able to do is break it into two smaller tables, and if each of these tables is in the appropriate normal form, then we decompose the schema so that we've eliminated the kind of redundancy and update problems that I talked about in the previous video. So all of these things, the notion of keys, the notion of rewrite rules, the notion of normal forms, and the notion of decomposition make functional dependencies a very powerful tool that we can use to analyse and improve our database schemas.